in a language that has loops. So when loops are taken away from you, then it's easier to appreciate the power of recursion because you are not left with anything else. But then from here, we'll go on to algorithms which cannot be done with loops, and we'll see them shortly. Another thing which, if you pick a very advanced C++ book, or um, which mostly not talks about syntax, but which talks about practices that good programmers need to adopt. And you would see countless pages spent on discussing that you should avoid changing things. You should make new variables for things to keep, and as far or as much as possible, not change anything. And that's an advanced topic because, again, the language doesn't force it. If the language doesn't force it, then it's discussed as a habit or as a design principle of senior programmers and so on and so forth. But in Haskell, that's easy. You can't change anything. So you get into the practice of building these building blocks that help you in other languages. Finally, when you break your problem like this, you might end up with a lot of let terms that let, and you uh, set up those variables to finally give the mapping that, okay, in this mapping, I'm going to use them all. When you are writing a C++ function, you are intrinsically motivated to not think about the final return statement, but instead think about what building blocks can you make. And you would make, okay, I have this, let's make this variable, let's make that variable. I might need this, I might need that. And building them, your goal is to reach at the final thing that you want that function to map to or return in case of C++. But working in Haskell will kind of twist your mind the other way. You will start with what you need to map to or what you need to return, and work back from there what variables or what things you need. That's a principle we will keep talking about, and sometimes we'll spend a lot longer time with bigger problems. That the general principle of top-down design or top-down thinking, where you start from what you need and from there go backwards to what do you need to build that thing. So what do you need to build that thing, and from there get to the building blocks, and not just put the building blocks one on top of another in hope of reaching a final solution. So these are the kind of things that you will, if you give a fair and open-minded attempt to Haskell, you will learn naturally. And this is the things that we will try to kind of learn. So I gave you a practice question of merging two sorted lists. And that's where we are going to start from. So if you have to merge two sorted lists, you of course have two sorted lists, and let's start with sorted list of integers, and you end up with a sorted list. And you can, let's call the first sorted list S1, let's call the second one S2, and let's figure out how do we map it to a combined sorted list. So let's first of all think of the general case. So let's first of all think that this S1, and I'm not writing 6 here, so let me write as comments, that let's say this S1, I have pattern matched it to XSS, and the S2, I have pattern matched it to Y and YS. And in the general case, they are both non-empty. So let's think of the non-empty case first. What should I do in the non-empty case? What's the minimum amount of work? And remember, the minimum amount of work, you have two lists. If either list loses one element, you have a smaller problem. And as soon as I have a smaller problem, I would like to pass it on to merge prime. And you know now that merge prime is a hypothetical thing that we will later take away. But I'll keep writing the prime. So our mind kind of keeps trusting it's something we don't have to bother about. Yes, so we want to compare the head of both elements. We don't want to take the minimum of one list because the lists are sorted. That's what we said, that these two are sorted lists. And we assumed, again, last time, another thing I said, that whenever writing such functions, think of the general case first. And from there, you can go on and figure out the special cases later. So I could end up with something like S1 and YS, either this thing or this thing. And again, it's not syntax yet. अभी मैं चीज़ें आगे पीछे करनी पड़ेंगी, but this is in principle what I want to do. One of these things. As soon as I know कि Y पहले आना है, then अगर मैंने Y निकाल लिया तो even though कि S1 में से कुछ नहीं निकाला, the problem is already smaller. The problem is smaller, and for smaller problem, I don't want to work on it. And a lot of people at this point will try to do a little too much. And that's the thing that you kind of want to control yourself. You want to do the minimum possible work, and there will be some more examples here today there where this thing will become more apparent. But this is the thing, and yes, so we have to at some point compare x and y. So x agar y se bada hai, so then we have to do this case, and kind of otherwise we have to do this case. Okay, so that would solve my general solution. I don't, so unlike a piecewise function, Haskell में the second case में implicitly first case की negation शामिल होती है. So if this is mapped, तो वो इस पे नहीं आएगा. So that's why in the second case, I don't have to explicitly say x less than equal to y. Even though if I say it, it doesn't matter. कोई मसला नहीं होगा, but I don't have to. ठीक है, so ये दो cases बनेंगे. If I consider that my lists are not empty.